So X is the score on a dice, a fair dice, so 1, 2, 3, 4, 5, 6. Probability 1/6 for each one there. So to find out the expected value of X, the mean of one throw, we probably know that one already, don't we? It's 3.5. 3.5 is the mean of the dice. Now the variance, I can't remember what the variance was, and so I could just go through and do all of that, but should we just do it on the calculator quickly, seeing as we remember we've got a nice calculator that does it. Let's clear everything that's there already. Wonder what I was doing last time there. And we've got 1, 2, 3, 4, 5, 6, and the probabilities of each of them is 1/6, 1/6, 1/6, 1/6, 1/6, 1/6, and when we go to the calculations, the one variable calculations, yes, we knew the mean was that, and here we've got the standard deviation, so we've got 1.707, and we're going to square that because that's just the standard deviation. I can do that, of course, in here, so variables, statistics, result, where was that? No, it's X, there it is there, and if I square that, I get 2.9166 recurring as my variance. But that's just one throw, and we're going to throw this 35 times. So if we let X bar be the mean of the 35 of them, then if we use the central limit theorem, then these will be normally distributed. The mean will still be 3.5, but the variance will now be 2.9166 reoccurring divided by 35 of them, because we're rolling this 35 times. I wonder if they've done anything on purpose because of that, because that's annoying. Find the probability that the mean of the scores is more than 4. Find the probability that X bar is greater than 4 for all of that. So shall we, we've got that there. Shall we store that? Shall we put answer into, just put that in a letter there to bring that back up later when we need it. Menu, distributions, normal distribution. We want a more than 4 with a standard deviation of the square root of that thing we just put in there, divided by 35, because there's 35 of them, and we have a mean of 3.5. Gives us that tiny bit down the end there, 0.0416. 0.0416. Just looking at it, it's 4163, so we're fine with that. And part B, find the probability that the total of the 35 scores is less than 100. 35 scores is less than 100. Why don't we just do 100 divided by 35 to find out what the mean's going to be then? Should we just do that? And it's less than. So if I just go back one page from there, this time I want a less than, I want 100 divided by 35, so I want to be less than 2.857, and just do that, and the less than value there, 0.0129. 0.0129. Looking at it more carefully, it's 12976, so maybe if I'm rounding that, it should be 0.013. So I want the probability that X bar is less than 100 over 35, and that gives us that.